Hello everyone, here's a question based on structural and stereoisomers. The total number of possible isomers considering both structural as well as stereoisomers of esters of molecular formula C5H10O2 is how many? We have to write down all the isomers involving ester functional group. So let's do this one by one. Number one, we can write butyl methanoate. That would be hydrogen and then C double bond O and then 1, 2, 3, 4. This is butyl methanoate. And then number 2, we can also write 1-methyl propyl methanoate. That would be hydrogen and then C double bond O and then 1, 2, 3 and then a methyl group at one position. Either you can call this as secondary butyl formate or 1-methyl propyl methanoate. I am going with the systematic IUPAC nomenclature. So this is 1-methyl propyl methanoate. Now for this isomer we have a chiral center at one position, isn't it? So we have a chiral center here because there is a hidden hydrogen here, that is one unit. So hidden hydrogen, methyl group and then ethyl group, and then this entire unit can be considered as one unit. So therefore that carbon atom there is chiral, which means enantiomers are possible. Therefore we have to consider both R and S configurations, which means we have to consider this as two isomers, not one isomer, isn't it? So therefore I am going to write number 4 because these are two isomers. I am going to write it as number 4 so that we don't miss the count. And then number 4, we can also write 2-methyl propyl methanoate. That would be hydrogen and then C double bond O and then 1, 2, 3 and then a methyl group at second position. So this is 2-methyl propyl methanoate. And then number 5, we can also write 1, 1 dimethyl ethyl methanoate or tertiary butyl methanoate. That would be hydrogen and then C double bond O and then a tertiary butyl group. Once again I am going with the systematic naming. So therefore this we can call it as 1, 1 dimethyl ethyl methanoate. And then number 6, we are exhausted with the methanoate thing. Now we will go to ethanoate. So that would be a methyl group and then C double bond O and then 1, 2, 3. So this will be propyl ethanoate. And then we can also write isopropyl ethanoate. So that would be CH3, C double bond O and then a isopropyl unit. So the systematic IUPAC name for this one is 1-methyl ethyl ethanoate. 1-methyl ethyl ethanoate. We are exhausted with the ethanoate thing. Now we will write propanoate and then number 8, we are going to write ethyl propanoate. That would be 1, 2, 3 C double bond O and then a ethyl chain attached to oxygen. So 1, 2. So this would be ethyl propanoate. And then number 9, we are going to write methyl 2-methyl propanoate. This is one isomer that many students miss. So we put a propyl chain and then C double bond O and then a methyl group at 2 position and then oxygen and then a methyl group. So this is methyl 2-methyl propanoate. And then number 10, we are going to write a butanoate isomer. Only one butanoate isomer is possible. So that would be 1, 2, 3, 4 and then C double bond O and then a methyl group. So this is methyl butanoate. So these are the 10 isomers that are possible, considering both structural as well as stereoisomers. Only the secondary butyl formate has chiral center. There is only one isomer that has chiral center, that is secondary butyl formate or 1-methyl propyl methanoate. That is the only isomer that has chiral center. So therefore 10 is the correct answer for this question.